Alright guys, welcome. So I thought I'd do this video just to kind of demonstrate the lab from before. I know I went over a lot of some stuff, but I wanted to make sure that I filled in any gaps, or if you just wanted another set of examples, then this is the video for you. So I basically copied and pasted one of the problems from the lab, and then the other ones are very similar. I just changed up the numbers, so this should be very helpful to you if you're doing that lab and turning that in. So all right, let's go ahead and get started. So part A, you want to use Excel to sketch a graph of the bell curve with a mean of 0 and a standard deviation of 1. So generate the x values in column A, ranging from -3 to 3 in increments of 0.5. So actually, we're going to do 0.5, but we're also going to do increments of 0.1 because I want to show you how the graphs change depending on the increment. So we'll do both of those so we can get you some practice. All right. So we're going to go ahead and type in our x and our y for column A and column B, and we want to go from -3 to 3. So there are a couple ways that you can do that. You can do equals, click on that, and then add 0.5, and then continue that pattern. Go all the way to 3, or what you could do, you can type in -3 for your first number, click on that -3 cell, then you want to go to over here, you see this down arrow with the box, that's the fill button. So you're going to click on that, click on series, make sure that column is selected because you want to put it in a column. The step value is going to be 0.5, and then the stop value, we want to stop at 3. Okay, so then we can OK it, and there you go, and it fills it in from -3 to 3. All right, so that's one way that you can fill that in. Now let's go ahead and do the actual values for the bell curve. So you're going to do equals norm.dist, parentheses, select your x value, comma, we want a mean of 0 and a standard deviation of 1. And then we want to do false because we don't want the area under the curve. We just want to graph the curve, not the area. All right, so that's false. Enter, then click on the cell, hover over the bottom right corner until it turns into a black crosshairs like so, double click, and you should get all your values populated. Now we can go ahead and insert the graph. All right, so we're going to insert line chart, 2D line. All right, so now we want to go to select data. We want to select our y values. Edit the x-axis, then select your x values. Okay, and that is our curve right there. All right, so it does look like a bell curve. Now, because the increments are 0.5, it looks a little choppy. So if you want to make it a smoother bell curve, you're going to need a smaller increment size. So I'm going to show you how that looks like if you change the increment size to 0.1. So let's go ahead and do that real quick. So again, I'm going to go ahead and delete all these. Now I'm going to click on the -3. I'm going to change the increment to 0.1. All right. All right, so now let me just delete all of this and start fresh. So then we go norm.dist, select your x value, 1, 0, and false. Oops, I reversed these. This will be 0, 1. All right. Okay. Let me double check our numbers here. Okay, so now we're going to select our data. Oops, sorry. So then we're going to go to select data, select our Y values, edit, select our X values. Okay, and then there is our curve. All right, so notice it looks smoother than before. All right, so that's just to kind of show you the difference between the increment values. All right, so now, next thing we're going to show you, we're going to look at part B. Find the area to the left of 1.5 on a standard normal distribution. All right, so that means that we're looking at, the standard bell curve, and we're looking at the area to the left of, remember, it starts at 0, -1, -2. We're looking to the left of -1.5. All right, so we need a function for that. So we're going to do to the left. So we want norm.s.dist. The S stands for standard deviation. Notice it's looking for a z. See that over there is looking for a z, which we said was 1.5. So we're going to type in 1.5. Cumulative, we want the area to the left. Okay, so when you're looking for area, you always want this to be true. Okay, so the area to the left is 0.93319. All right, when you show your work on Excel, just kind of type in the function that you used, or copy paste it, whatever. Kind of type in the function. So we did that, and then we put true, and then we end up getting the number. So we end up getting the probability that z is less than 1.5 is, and then type in your answer, 0.93319. Okay, that way you can show me that result. And then for this, you can copy and paste the table. So if you had like the table of values like we did before, then you can copy paste that. Just kind of highlight it, right click on it, copy, and then you can do your graph. Okay, you can copy paste that onto here. All right, and there's your chart. You could do the same thing with the graph. Okay, that way you can show me your results. All right, so now let's do the area between -1.5 and 2.5. So in order to get that area, remember that you're looking at between -1.5 and 2.5. So you're going to find the area to the left of that, which is from the chart. Normally you look it up from the chart, but we're going to use the function on Excel, right? We're going to use the norm.s for -1.5, and then we're going to get the area to the left of this, we're going to use the norm function for that, and then subtract those two. Okay, so we're going to do the bigger minus the smaller. So we're going to do the norm for the 22.5, the norm for the -1.5, then subtract them. All right, so we're going to do norm.s.dist, and our first value is 2.5, the next one is -1.5. So we're going to do 2.5, then true, minus, repeat the function, -1.5, then true. Subtract those together, and then you get your area of 0.92698. All right, 0.92698. So then we'll show our work here. Wrong one. We want to do it on here. So kind of type in our work. And we got the answer. And then so this is the probability that z is between those guys. And that's 0.92698. All right. And that's an example of showing your work so that I know that you know how to do it. All right, so now find the area to the right of z equals 2.1. So this is when we do to the, remember, just like we did in the actual lesson, right? If you want it to the right, you want this side, then you need to take the left and subtract it from 1. So you need to do 1 minus this probability. And to get this, you're going to use the norm function, all right? The same one that we used. All right, so we got to do 1 minus the norm function. All right, so so let me get rid of this. So we got 1 minus the norm function. The value was 2.1, and then true. And that'll give us our value, 0.01786. All right, so then we want, so we did 1 minus norm, that norm function. All right, and that's the same thing as 1 minus the probability that z is less than 2.1, which is 0.01786. All right, this to show our work. Now we want the area to the left of 25 on a normal distribution with 20, mean of 20, and standard deviation is 3. So this time we gotta calculate the z-score. There's a function that calculates the z-score and finds the area, all right, for you. So we're gonna do that. Since we want the area to the left, we don't need to subtract from 1. We can just use the function, all right? So instead of norm.s, we're going to use the rect.dist. Instead of using the s here, we're going to just do norm.dist. That means that you're not looking at z-scores, you're looking at the x value, all right? So our x value here was 25, so we want to the left of 25. Our mean is 20, and our standard deviation is 3. And we want this to be, we want the area to the left. So yeah, we're going to do true. If we want a probability, we're going to say true. So that's it, 0.95221. 0.95221. So we want the probability that x is less than 25. Well, so let's write our function first. So we did norm.dist 25, 20, 3, and true, which is the same thing as probability that x is less than 25, which is equal to 0.95221. All right, just to show our work there. All right, so now we want to find the area to the right of 25. So now since we want to the right, that means we're going to subtract 1 from 1 minus, all right? Same, I think it's the same mean as standard deviation. And the same number, we just want to the right, okay? So we're going to do to the right. So we got 1 minus the norm function, 25, mean is 20, standard deviation is 8, and true. Let me make sure that that's correct. It's standard deviation is 20 and, or mean is 20, standard deviation is 3. So let's change that number. All right, there you go, 0.04779. Okay, so we did 1 minus the norm function, 25, 23, and true, which is 1 minus, so the probability that x is greater than 25 is the same thing as 1 minus the probability that x is less than, which is 1 minus, or which is, you know, we got the answer, 0.04779. All right, so we're going to do the area between 30 and 45. I'm not going to show my work on here. I'm just going to do the function. So we got to subtract between 30 and 45. All right, so we want to do the function twice. So 45 first and then 30, okay? So we're going to do the norm for 45. I believe it's the same standard deviation. No, it's Mean is 38, standard deviation is 10. So mean is 38, ST dev is 10. So we want to do that minus same function, but we want it for 30. All right, and then you have your, so that's your guy. Subtract them, you get 0.54618. All right, so that's how you do part G. So now we want, for this guy, for H, we want the Z value, so that's 10% of the area is to the left of Z. Okay, so looking at this, we want some kind of Z value so that wherever that Z value is, 10% is to the left. 10% is 0.10. All right, so we want to go backwards. Instead of finding the area, we want the Z. So we're going to use the norm inverse function. All right. So we're going to use norm.s.inverse, and the probability to the left is 0.10, and that'll give me my Z, negative 1.28. Okay, so that Z is negative 1.28. Okay, now we're going to do the same thing. Now this time they give us a mean of 12 and a standard deviation of 8, but you still want to do the same thing, but you want to find the x value so that 10% is to the left. Okay, so this time we're not looking at norm.s.inverse, we're looking at norm.inverse. Okay, so mean is 12, standard deviation is 8. So norm.inverse, not S inverse. 0.10 is our area. Our mean is 12, standard deviation is 8. Let me make sure that's correct. Yeah, mean is 12, standard deviation is 8. So that is our x value, 1.748. All right. And again, you want to show you the function that you used. So we use norm.inverse, 0.10, 12, 8, and that's it. Okay, so you want to make sure that you show your work. All right, so now we're going to look at the last problem. So for this one, you want to check for normality, which means that you want to use the normal quantile plot. Okay, so remember the normal quantile plot. You want your x value, then you want your counter, and then you want your your z-score with your quantile. Okay, so this is where you do the quantile stuff. All right, so remember the formula for the z-score / quantile. We're going to use the norm .s.inverse, and then we're going to take our counter from the second column, then divided by 2 times however many numbers we have. We'll call that n. Okay, so our n is our sample size. So that's sort of like our formula. All right, so we're going to go ahead and I'm just going to label my columns. So I got x. I'm going to do my counter. My counter is basically odd numbers, a set of odd numbers that we need for the formula. Okay, so now we need our z-score or quantile, which our quantile is used for our z-score. All right, so then we're going to type in our x values from here. All right, so I'll be back when I type in those x values. All right, so I typed in the x values. So now that I typed in the x values, now I can do my counter. So I'm going to start with 1 and I'm going to go by odds. All right, so I can highlight the numbers, use that shortcut that I showed you, and get all the odd numbers. Then we need our formula for the z-score. So this is where we use the norm.inverse, the s-to-inverse. And we are going to use the formula. So we're going to do our counter divided by parentheses 2 times the amount of numbers we have. So here we have 2, 4, 6, 8, 10. We have 12 numbers. So 2 times 12 in the denominator. And that'll give me my score. So that's the formula. Then I'd use the shortcut, click on the cell, go on the bottom right, double click, and there's your guy. Now we're going to do a normal quantile plot. So you're going to go to Insert. You want to go to a scatter plot. So we want to use this option, Scatter. Click on that first option there. All right, now we want to select data here. So let me move this to the side. Select data. Select your z-score quantiles. Then edit here. Click on X values and select your X values. Oh, one thing first, guys. I forgot. I always forget I always forget this part of it. So you have to sort the data in order. So we need to show you how to do that. So highlight all your numbers, then go to data, and you want to sort. Okay, so you want to sort from smallest to largest. You want to continue with the current selection. And there you go. Okay, so it'll sort your data, and then we can actually do the graph. So let me go and show you the graph again. So insert, then your scatter. Move that to the side, select data, select your Z's, edit, select your X, go to type, click on X values, select your X values. Okay, and okay. All right. So now you have your chart. So now what you want to do at this point is you want to click on this icon, the plus icon. You want to add a trend line and click on this right arrow. I'll move this a little bit so you can see it. More options. Then goes all the way down to display R squared value on the chart. All right, this will give you an R squared value of 0.866. All right, so the closer that value is to 1, the better. All right, so actually what you need is the R value. Okay, so to get the R value, you would want to take that number, take the square root. So type equals square root of that number. And the closer that number is to 1, the better. So that's pretty good. It's 0.93. So based off of this, it looks, pretty good to me as far as normal. So we'll say yes, it seems to follow a normal distribution based off of, this trend here. All right, and that's all you got to do, guys. So again, you're going to copy paste the graph, copy paste the chart. So I'm going to copy paste that onto my results. You want to show your work here. So copy paste your graph with your trend line, your chart that we did, all that stuff. All right, so good luck, guys, and this will be due on in a few days, so make sure you you get it done. All right, see you guys. Good luck.